In this video, we're going to take a look at some of the properties of two-dimensional and three-dimensional shapes with the goal of reinforcing for you just how important it is that young people have the opportunity to personally experience the shapes themselves and not just rely upon a picture. As I've arranged these here, you'll notice that everything in this column, if we look at it just in terms of two dimensions, could be confused for looking circular, just as everything in this column could be confused with looking rectangular, and in fact the top two almost look like they could be squares. This is a common problem with young people when they see a picture in a textbook of something that they haven't had actual physical experience with, because once you've experienced this in the full three-dimensionality, not just as a picture in the textbook, we get a totally different perspective. So you see what we have here is we have something that, yes, does look circular in cross-section, but is actually a cylinder, like a can. And so if I had not had personal experience with what that object might look like, it would be very easy for me when seeing it in a textbook to confuse it for a circle. Just like the same here. This looks very circular when I look at it, but when I pick it up and I start experiencing it in three dimensions, I realize what I have is a sphere. And so even though it might look like a circle in the textbook when it's flat on a two-dimensional picture, when we experience it in the third dimension, we realize that it's not as simple as just a circle, it's actually a sphere. Take a look at this one. Again, it looks very much like a circle. And yet, when we look at it in three dimensions, what we see is we see that it's a cone. And in this case, it's a circular cone, isn't it? And so we see a much different picture if we've had actual experience with it in three dimensions as opposed to just seeing these two-dimensional representations. Up here, for example, even though this one looks like a square, and I'm trying to get my sphere so it stays put here, I may have to move it. Yeah, I'm just going to move it off. Even though this looks like a square, when we lift it up and we start exploring it, we recognize that, oh my, it's a six-sided figure. Each side is a square, and so you could call this a cube based on our experience with other three-dimensional figures. This would be a cube. What do we have here? Well, it looks like a square if we just see the two-dimensional piece of it, but when we start looking at it in the full three dimensions, what we see is that it's a pyramid. It has a square base, and then it has triangular faces. So this would be a square triangular pyramid. Finally, for completeness sake, even though this looks like it's just a rectangle, when we experience it in three dimensions, we realize that it's a rectangular prism, that it has dimensions of height, width, and depth that we have to account for if we're going to fully understand what that shape is all about. And so, in closing here, we have to be very, very careful, especially with young people, that we don't just limit ourselves to the two-dimensional pictures. These pictures are extremely easy for young people to misunderstand, and we have to supplement that by giving them hands-on experience with the actual solids themselves, so that we can see and feel and gauge each of the three dimensions that goes into making up each of these very, very important geometric shapes. So let's continue this just a moment. Assuming the students now have experience with not only the textbook two-dimensional picture, but also the three-dimensional aspects of each of these figures, one of our jobs is going to be, how do we create a representation of what the students have seen to help them recognize it? Clearly, if we just draw a picture like this, we're going to be hard-pressed to see if it's a cylinder, if it's a circle, or if it's a cone. And so when we draw something like this, one of the things you want to do is you want to make sure that it captures the essence of the figure as best you can in 2 dimensions. And so in this case, we see we have a circular base, and we see that it comes up to a top like this. And so that might be a better sketch for what we have going on here, that it looks a little bit more like a cone than if we were to just draw a circle, or alternatively, if we were to just draw a triangle. And so this would be preferred as our representation. There's no way that this would carry enough information, and this would not carry enough information. But where this has features that include all 3 of the dimensions, I hope you can see how that actually gives us a better picture for students to work with in terms of how to draw a sketch of what that might look like. Since we're dealing with 3-dimensional figures, it's important that we try to find some way of showing each of the 3 dimensions. That's why we tried to show the circular base and the triangular cross-section for the cone. So as we look at the cube, this is not necessarily the best sketch. If we were to just draw that sketch, it would look like a square. What we'd like to have is we'd like to have something that captures all 3 dimensions of the cube, and in particular so that we could label them, so that we would know that this distance is equal to 1, that this distance would be equal to 1, and that this distance would be equal to 1. You notice now that what we're doing is we're taking a specific way of putting that cube so that we can see all 3 of those dimensions. And whenever possible, we'd like to be able to label those dimensions, because that becomes part of the record of action that we're referring to. Now, because the object that we're acting on is the geometric shape itself, the record of action of anything has to include the sketching of that action. So if I take a look at what this might be like, you notice that we wouldn't just draw the square that's the base of the pyramid, but somehow we would have to show the triangular features of the pyramid as well. So perhaps we show something that shows the square base of the pyramid, and maybe we draw some dotted lines here to show the internal of the pyramid as well. With practice, you can get where you can represent each of these figures, but it does take practice. For example, in looking at the cylinder, what are the key features of the cylinder we have to preserve? Well, first, it has a circular cross-section, and second, it has a height. So as we draw our sketch, we have to make sure that in some fashion we show the circular cross-section and that we show the height. And so again, in an ideal world, we'd want to be able to label the key features, so we'd probably label the radius, and then we would also label what this height is as well. This way, the record that we're creating from a sketch perspective can preserve the 3-dimensional aspect of the figure itself, while still being able to put in 2 dimensions as we draw this out onto a flat sheet. So here again we have a rectangular prism. We want to preserve all 3 of the dimensions, and so it looks like we have something like this. What you will find is that it's not immediately obvious sometimes how to draw these sketches, but with practice you can get better and better at it. And this is very important, because when students think about these things, they have to have a way of recording their work that accurately reflects the 3-dimensional aspect of the shape itself, but can be recorded in the 2 dimensions that they're going to see in terms of papers and textbooks and so on.